Hi guys, we're going over page 6 of your Regents Review packet today. Both of these questions we have not covered in class yet. They're from our data and statistics unit that should be at the end of the year, but hey, can't be too ready to start, right? So one thing I need to warn you about, our data statistics questions on the Regents are going to be wordy. I mean, obviously, there's 2 questions, it takes up a whole page. You cannot let all of these words discourage you from doing this question or getting overwhelmed at this question, because really they're not that bad once you know what you're looking for. So I'm going to do my best to kind of teach you right now, okay? So this one, number 16, we've got a study conducted in New York City. 212 out of 1334 participants had hypertension. Kim then ran a simulation. So she said, okay, if 212 out of 1334 people have hypertension, I'm going to run this on a computer and see what probability or what proportion of people across New York City would have hypertension as well. So here's her output. This is a dot plot, okay? We learned these in Algebra 1, so every dot represents one simulation that was run. And I want you to notice is that this dot plot is symmetric, okay? It is mound-shaped, where most of the people here are in the middle, which is what we would expect to happen, okay? So the question comes out at a 95% confidence level. The proportion of New York City residents with a hypertension and a margin of error are closest to blank. All right, so first thing we're going to do is we're going to concentrate on proportion. That's just a percentage or a probability that someone has hypertension. So if we look at this given situation, we know that 212 people have hypertension out of 1,334. And that's your probability or your proportion. You type that into a calculator. And of course, I've got to open up one. I don't even know what's best, that stinking light above me. 212 out of 1334. And remember, we want to stick a decimal point in there in order to change it. 0.16. That rounds. All right, so I, as a good test taker, would come on over here and say, let's get it. There we go. Probability is 0.16. That's these two, not those two. Knock them off. Okay, so you're down to a 50-50 shot of guessing. The next thing we have to do is we have to calculate this margin of error, okay? Because whenever we take a study, there's mistakes that happen, whether they're human or mechanical or whatever. The thing in Algebra 2 that you really have to pay attention to is this 95% confidence level. In Algebra 2, that means 2 standard deviations. Okay, now a lot of times on these questions, up in a corner, up here or over here, what they'll do is they'll give you the mean and they'll give you the standard deviation. So if that happens, all you have to do for a 95% confidence level is multiply the given standard deviation by 2 and you're done. Unfortunately, on this one, they do not give you those pieces of information in a corner. So you have to calculate the standard deviation and then multiply it by 2. That is a formula that unfortunately you have to have memorized. It is not on your reference sheet. Okay, there's no way around this one. But like I said, you're down to a 50-50 shot of guessing. And where do we always guess? If we have to, we guess one of the ones in the middle. So let's see if that works out. Let's see if this is the answer, okay? The probability, or not the probability, the formula, you can kind of see, I had to start over. The formula for standard deviation that you have to have memorized is a square root. And inside the square root, you're going to have a fraction. You take the proportion that you just got times 1 minus the proportion that you just got over the total number of people that were surveyed to begin with. Now, remember, I said 95% confidence level is 2 standard deviations. So after you calculate this, you would have to multiply your answer by 2 to get a 95% confidence level. Have to memorize this formula, okay? So when I plug in my numbers, the proportion I got was 0.16. 1 minus 0.16 over the total number of people that were surveyed. Well, how many people were surveyed here? 1,334 participants. That's how many people we surveyed. We're going to take that. We're going to multiply it by 2 because 95% confidence level. Then you pick up your calculator and you let my lights do crazy things to your eyeballs. I don't think there's any good way around that. I'm so sorry. So, square root, fraction. It was 0.16 times 1 minus 0.16 over 1334. Should I multiply it by, well, let's do that. There it is, okay? But then we have to remember with a standard or a 95% confidence level, we want 2 of them, 2 standard deviations. So the answer is 0.02. And our guessing, if we were gonna guess, look at that, it's one of the ones in the middle. We got it. Okay, now this one I asked you to try because I think you're smart enough to figure this out. We've got a scenario that is an observational study. So observational, you have to see it happening. So let's just go through all of them because again, we haven't talked about them. Number 1, for a class project, students in health ask every 10th student entering the school if they eat breakfast. So what's happening here is you are asking people. That is not observational. That is called a survey. Okay, when you ask someone a question and you document their answer, that is a survey. Number 2, social researcher wants to learn whether or not there is a link between attendance and grades. She gathers data from 15 school districts. So how do I know if you're at school or not? I have to look. I have to see who is in my class, okay? Because I have to look and see if you are here or not, that is an observation. There's your answer. Just quick, the other ones. A researcher wants to learn whether or not there's a link between children's daily amount of physical activity and their overall energy level. During lunch at the high school, they distributed a short questionnaire. Well, questionnaire. Again, that's another survey. You're not seeing if people have more energy, you're asking them if they have more energy. And number 4, 60 seniors taking a course in advanced algebra concepts are randomly divided into 2 classes. One class uses a graphing calculator all the time, and the other class never uses a graphing calculator. Sad for them. A guidance counselor wants to determine whether there is a link between graphing calculator use and the student's final exam grades. So what happens here is people are randomly divided into 2 groups. Okay, you guys do this in science all the time. When you do that, that is called an experiment. You have your test group and you have your control group. Okay, so we're testing to see if the calculators work, so we have to test that on a group that isn't using calculators and then see how they do on their exams or whatever, okay? So these are different methods that we can collect data. We can do a survey, we ask people questions, or we distribute a paper and have them answer questions. We can do a study, which is where we watch and document them ourselves to what is happening. And we have experiments where we divide things into groups and study if what happens with one group had an effect or not. So there you go, guys. As always, if you have any questions, send me an email. Oh my goodness, that was my kid. Okay, I'll talk to you later. Bye.